So now let's look at higher order trinomials. Trinomials have 3 terms, and we always want to look for our GCF first. That does not change. No matter what our exponent is, we always want to find that GCF. So in this first example, you do have a GCF. And the GCF here, I would like to make that a little thicker, sorry. GCF here is negative 2x squared. I get negative 2x squared. Left over is x squared plus 3x minus 54. And then now this is something that I'm comfortable with. It's a trinomial quadratic that I can just use photat on. So go ahead, try to photat. So I went ahead and did photat here. I got factors of negative 54 that add to 3 are 9 and negative 6. So I wrote those factors out and I brought my GCF through. Don't forget about that. It makes a difference. And this is my final answer. Nothing else there can be factored. So if we look at example number 2 here, it has a similar structure to something that we would use photat on. However, my first term is x to the 4th and my second term is x squared. The only difference that makes is when I write my factors out, instead of having something x plus factor 1, x plus factor 2, or whatever your factors are, it's going to end up being x squared and x squared because I need them to multiply to x to the 4th. So I can still use photat, that doesn't change. So factors of that add to 36, negative 13. Go ahead, try this out. See if you can get to the end of the problem. So I went ahead and did photat here. I got negative 9 and negative 4. So my two factors were x squared minus 9 and x squared minus 4. But then I noticed that both of those could be factored even further using difference of squares. Remember, we need to completely factor, which means I need to get it down to a line where nothing else factors. So what's highlighted in yellow here is all linear. So I do not need to factor any further. That is completely factored. So just be on the lookout when you have problems like this. You're probably going to have to factor more than just one time. Looking at number 3, it has a similar structure, but a is not equal to 1, which means I'm going to have to use the AC method. So AC here is negative 15. Factors of negative 15 that add to negative 2 are going to be negative 5 and positive 3. So my first term stays. I want to split up my middle term. So I'm going to do plus 3p squared instead of just p because I need them to be a p squared term. And then minus 5p squared minus 5 equals 0. Go ahead, try to solve that out. So I completed the factorization here and I got 3p, I'll highlight it. I got 3p squared minus 5 times p squared plus 1 equals 0. I need to solve because it said equal to 0. I solved the second factor for you, p squared plus 1. Subtract 1 from both sides. When you take the square root, you get p equals plus or minus I. I wanted to do this second one with you. So if I add 5 to both sides, divide by 3, I get p squared equals 5/3. When I take the square root, I get p equals plus or minus, don't forget that, the square root of 5 over the square root of 3. I need to rationalize here. So I end up with p equals plus or minus the square root of 15 over 3. And that is my other pair of answers. Why don't you pause the video and try number 4 on your own. In number 4, I did have a GCF once I set it equal to 0. My GCF was x, so I took that out and I left it on the outside over here. When I factored that out, I was left over with x to the 4th minus 10x squared plus 21 equals 0. So I can photat that. Just remember that my two factors are going to have x squared and x squared instead of x and x. When I factor that, neither of those factors are perfect squares, so I cannot use difference of squares. So I just apply the zero product property and solve, and I end up with x equals 0, x equals plus or minus the square root of 7, and x equals plus or minus 3. And those are my roots for this polynomial. Number 5 is similar. Instead of having my highest exponent be a 4, it is a 6. Things don't really change. Instead of the two factors being x squared or x, they are going to be in the form of something x to the third, something x to the third, because x to the third times x to the third equals x to the sixth. However, here a is not 1, a is 6, so I need to AC method here. Whoops. 6 times negative 2, negative 12. So I want factors of that add 2, negative 12, and 1 are 4 and negative 3. So I'm going to split my middle term here, keep my first term the same, 6x to the 6th, minus 3x cubed, because that middle term is an x cubed, so I always want that exponent to be the same as that middle term, plus 4x cubed minus 2. Go ahead and do this out yourself. So after I split my middle term here, I can factor by grouping. I found the GCF of this side to be 3x cubed, and what was left over was 2x cubed minus 1. And then I found the GCF of this side to be positive 2. So I got plus 2, what was left over was 2x cubed minus 1. So then my final factors are 3x cubed plus 2 times 2x cubed minus 1. That is done. None of those can use sum and difference of cubes. Even though it might look like it, the coefficients don't allow me to. So that is completely factored. Let's look at number 6. Similar structure. So I know there's no a value here bigger than 1. So I know I'm just going to have x to the third and x to the third. So I want factors of that add 2. We got 9, negative 10. It's going to be negative 9 and negative 1. So here I can actually use difference of cubes on this first factor. So I'm not completely factored. I need to difference of cubes that. So the cube root of x cubed is x. The cube root of 1 is 1. So I'm going to have a minus b times a squared plus ab, which is just times 1, so it's just x, plus b squared, which is just 1. And then I bring down my other factor. Now I'm completely factored. This here, this quadratic here, does not factor. I'll do a different color so it doesn't look like that's the answer. This doesn't factor. So quadratic formula. Go ahead and solve. So when I went to solve this out, I rearranged the order a little bit. I went and did my quadratic formula on that trinomial, and I ended up with negative 1 plus or minus the I square root of 3. And then when I solved the other two factors, I got x equals 1. And then for this one, I took the cube root of both sides, and you don't need plus or minus for cube root. So it's just the cube root of 9. We're almost done here. 2 more. The 2 more that we're going to do are factor by grouping, which you are super comfortable with, or should be at least from working with quadratics and AC method. So first thing we want to do is still always look for our GCF. There actually is none in this first example, so I can split down the middle and just do my factor by grouping. There was no GCF in this one, like I said, so I just went ahead and split it down the middle. I found my GCF of this side, which happened to be 5n squared. and what I had left over was n minus 2. And then I went and found my GCF of this side, and that was positive 3. I like to put the sign there so I don't mess it up when I write my factors. My two factors are 5n squared plus 3 and n minus 2. There is nothing else to factor there, so it is complete. The last one, we've got 4 terms. There is a GCF. Take it out before you do anything else. You can jump to factor by grouping here, but I think it's better to just take out the GCF from the beginning. So my GCF is x. I'm going to be left with x to the third plus 7x squared minus 3x minus 21, all equal to 0. Now I can factor by grouping what's in my parentheses. So I'm going to bring my GCF down. I'm actually going to use a bracket here because I'm going to have some nested parentheses. So the GCF of this side here is x squared. So I'm going to write x squared. What's left over? It would be x plus 7. And then the GCF of this side here is negative 3. What's left would be x plus 7. So then my 3 factors are x times x squared minus 3 times x plus 7 equals to 0. Be careful, you could have difference of squares show up here if this, I'll just put a note, if this was a perfect square, then you could use difference of squares to factor again, but it's not, so I don't have to worry about that. I can just set my factors equal to 0 and solve. So I'm going to have x equals 0, x squared minus 3 equals 0, and x equals plus or minus the square root of 3. So I've got a couple answers here, not too challenging. Again, I said you're pretty comfortable, or I believe you're pretty comfortable with factor by grouping. And that is factoring higher degree polynomials.